Okay, so I will start with a short presentation of the aWISH project, where this workshop is part of. So first question for you also, again, just to know if you know already the aWISH project. So please go to the Mentimeter and already answer this question. I will see the answer. Now you can see, I think, the answer. If you can. Maybe some people are part of the project, so just to know if you already know this project or not. Okay, so most of the people know already about this project, so thank you for your answer. I will continue. Okay. So in this project, there is a few partners for different countries of Europe. I will not tell everybody, but you can see in this slide. So the main aim of this project is to develop a large-scale automatic welfare monitoring of animal-based indicators, maybe mainly on the slaughterhouse. So this is a project in pigs and broiler. So in this project, there is already monitoring of 70 novel animal welfare indicators. So as I said, mainly at the slaughter, but also in the different part of the production, so rearing, fattening, loading, transport. So some example of what is monitored and which technology is developed to monitor those novel animal welfare indicators. There is stress monitoring, stress vocalization monitoring, stress or pain vocalization, bruises, skin lesion, and liver, lungs, ring fracture, foot pad dermatitis on hogburn, but also tail biting, dead on arrival, and condemnation. So all those welfare indicators are monitored within the project with new technology, which are developed in this project. So I will not describe everything, but just to say that we already developed an animal welfare catalogs to reference all the animal welfare indicator. A data platform is also developed to collect all the data from all those technology, but also routine data and technical data from the different farms involved in pigs and broiler. There is also a best practice guide developed that you can also access on the website of the aWISH project. And this started this year, but also next year we will continue the work with assessing the impact of this development, of this new technology development on environment and socioeconomic. So that's an important part also that will be done soon. So that's a general presentation of the project, but in fact there is 6 pilot slaughterhouse involved in this project. So 4 pilots in pigs and 2 pilots in France and in Poland on poultry, led by Plukon and scientifically the ITAVI in France and scientifically IGBZ in Poland. So these 6 pilots are involved in the development of the technology and help us collecting all the data from the farms to upload and feed the data platform for accessing it to feedback loop for the farmers, for example. So that's a short presentation of the project, and maybe if you want to have more info, you can go to the website and contact the leader of the project, that is Ilvo. And here you have the mail, and as I said, you will receive the presentation, so you can also have this mail in the presentation afterwards. And we have a website also for the aWISH project, where you can have all the news and all the deliverable publication, etc., that is produced in the project. So we will continue with the second presentation of Laura Warin from ITAVI on transport-related challenges for broiler and key issues description. So Laura, tell me when you want to go to the next slide, and I will.
Thank you, Warin, and thank you everyone for attending. So if you can go to the next slide. I will also ask you some questions, as Pauline did, and the first one, as we will talk about key issues, what are, according to you, the key issues during transport regarding animal protection? So please write 1 word per ID, so it will be easier to read the results as it will be displayed with the word cloud. Should be okay now.
Yeah.
And you can add as many words as you want. What about duration, density, temperature, so heat stress, cold stress, distances, and also regarding fractures, stress. So we will talk about these topics. So you have a good overview of the key issues.
Stress, fractures.
Yeah, space, freedom, hunger also.
Okay, so I think there is no more answers. Or yes, there is. It moves.
So we will mainly talk during the presentation on available space, talking density. Also, we'll talk about hunger and thirst. And we will also talk about temperature, so heat stress and also cold stress, and on the duration. So your ideas will be discussed today.
Okay, so I continue.
So next slide, a bit of context for those who are not aware. So transport of live birds is regulated in Europe since 2005. And this regulation aims at harmonizing transport practices among European countries, but is perceived by some stakeholders as inadequate or insufficient. And following European, you can click, yes, thank you. Following European Commission recent engagements, a new regulatory proposal was made in December 2023 and is still under negotiation between member states. You can go next slide. So we can wonder why is it so important to regulate transport of live birds? Because the aim of the farmers, the catching teams, and the drivers is to minimize stress and lack of comfort during transport. However, the transport causes stress for broilers because it involves different noises, temperatures, light, so a totally new environment for the birds. Also quick handling and catching, and finally a restraint in containers during the transport. So next slide, please. So in order to minimize stress and or discomfort during transport, it is important to monitor birds during the transport. However, stakeholders face some difficulties because broiler flocks are very large flocks. There are a lack of visibility in the containers. It's difficult to see all the birds. Lots of noise also, and a limited scope for action. It's better to anticipate. So current animal-based measures, so-called ABM, are anyway routinely collected to ensure that everything was okay. Such as DOA, so dead on arrival. It mainly reflects hot and cold stress or unfitness for transport. Also injuries, bruises, or body parts entrapped between or inside containers. However, EFSA advises to consider more animal-based measures, and other than mortality, that really reflects the worst possible welfare state for a bird, such as posture, distress calls, denting, huddling, fluffing up of feathers, or shivering. And we were wondering what animal-based measures are routinely collected in your country to monitor broiler protection during and or after transport. So this is a new question, an open one that you can answer with the QR code. I think mainly mortality with DOA and also fractures, bruises at the slaughterhouse.
Temperature okay. Monitoring.
Yeah. Okay, mainly the same ideas. Okay.
Okay.
And in addition to these animal-based measures, please note that weather forecasts are also always taken into account to adjust densities in the containers, traveling hours, the use of curtains, and that environmental conditions, so for instance, temperatures, as it was written in the Mentimeter, are also sometimes monitored in the containers and that very few recent vehicles are equipped with air conditioning systems. So not in France, but yes, it's possible. So you can. So I will now introduce and describe 4 key issues associated with transport of live birds. And first, we will talk about transport duration. So literature review informs us that dead on arrival increases as transport time increases, as illustrated with a figure. So you can click twice, I think. And for example, we observed plus 19% of dead on arrival from a situation without any transport to a situation with a more than 4-hour transport. And in addition, DOA also increases as transport distance increases. So as a conclusion, longer transport duration, so time distance, increases mortality as it worsens the potential thermal stress, hunger, thirst, or discomfort for the birds. And regarding regulation, so currently there is no maximum total duration for the transport of adult birds, but it is required to water birds after 12 hours of transport. And as trucks are not usually equipped with drinkers, the total duration is mainly less than 12 hours. And moreover, drivers must also comply with national regulation on maximum driving time. So it's important to have it in mind. And the new regulation proposal gives a new definition of transport duration that now includes uploading plus downloading of the bird in addition to the journey, which raises many questions for stakeholders. And the new proposal also includes a maximum transport duration of 12 hours for adult birds. Next, another key issues we will discuss is regarding feeding and watering of birds. So hunger and thirst are basic needs that must be fulfilled in all welfare definitions. But during transport, birds encounter feed and water deprivation for different durations. So first, we will focus on hunger. So for hygiene and economic reasons, the optimal total feed restriction withdrawal is between 8 and 12 hours prior to slaughter. Less than 8 hours may result in fecal residues in the digestive tract. And if the feed withdrawal is too late, then it will increase the metabolism of the birds and heat production, and it could worsen the heat stress for the birds during summer, for instance. And after 12 hours of feed withdrawal, birds may experience intestinal suffering that is detrimental to their welfare. And also, please note that fast-growing broilers might experience hungry feeling very quickly after feed restriction, as they have a very high metabolism. And for the hunger part, the data would support the limitation of the fastening duration to 12 hours max. And regarding thirst, current available knowledge and thirst assessment methods are not sufficient to draw any definite conclusions, but water restrictions longer than 6 hours are likely associated with dehydration, but with a high variability between individuals, so it's not very clear. So it's difficult to conclude, and we clearly lack data to conclude on the maximum duration of water deprivation regarding thirst. You can go to the next slide. So currently, broilers are not fastened for more than 12 hours and not less than 4 hours prior to the transport. And water is available until the start of the catching, and they must be watered if journey is more than 12 hours. And in the new proposal, it is written that feed and water must be available during the transport, but it's not very clear if it concerns poultry because, as we discussed just before, it doesn't seem relevant for poultry to feed them until the beginning of the slaughter. And regarding water, even if it seems relevant from a welfare point of view to water the birds during the transport, it would require new trucks with drinkers, which could be very expensive, heavier trucks, so lots of issues for the transporters. Then another issue that is discussed concerns the available space, so stocking density and height of the containers. So different authors assess the impact of different densities in the containers on injuries and bruises. You have some figures here. And they observed more injuries and bruises at lower stocking densities, probably because birds have more space to move and are more prone to fall. And they also observed that the provision of more space during transport was sometimes associated with a reduced mortality, but only during summer, probably because it helps to reduce heat stress. Regarding height of the containers, literature indicates that a height from 23 to 46 centimeters enables more natural postures for the birds, but also more scratches, probably because birds have the possibility to walk on each other. So the conclusion, additional space does provide more comfort to the birds, but unfortunately does not seem to be as beneficial as expected, as it leads to more injuries, except during hot summer. So regarding the available space, so density, you have here the current regulation with the available space in square centimeter per bird. And we have a question for you again. So in your opinion, compared to the current regulation, how much additional space is required by the new proposal? So in a percentage, so plus 10%, plus 60%. So you have some proposals in the Mentimeter, and you have to select what seems the good answer to you. Plus 90% is could be very too high, and nobody vote for this one, but yes, plus 30 or plus 60. Okay.
Okay, I see there is some more questions, answers, sorry. Okay, so we will see
what is the correct answer.
The correct answer.
So the correct answer was plus 60% available space. So you have here the figures. I won't read everything, but yes, the new proposal would induce plus 60% available space than the current one, which could lead, regarding what we discussed before regarding literature, to more injuries. So yes, that's what is discussed. And regarding height of the crates, currently there is nothing in the regulation. And in the new proposal, it's written that broilers must be able to change posture without being disturbed by the height of the container, but there are no more details so there are no figures. And just to give you an example of the current high in France, used in France for different broiler live weight, and the EFSA recommendations, so that are aligned with what is currently practiced in France. And we were wondering, so in France, sorry, it wouldn't be a problem if the recommendation of the EFSA panel was applied in the regulation, but would it be a problem for you in your country? Because maybe you have a lower high of containers. So this is the question we ask you. So it's a yes/no question. Maybe for the one who answered yes, you will have the opportunity to explain, maybe with more detail, why it could be a problem in your country during the open session for questions.
Yes. If you did not scan the QR code, you can also use the code here with the figure, the 8 figures you can see here, and enter it on menti.com. If you did not scan the QR code, you can use this on menti.com. I hope it's clear for everybody. I did not see the chat, so I do not see the chat. So.
Okay. I think you can go back to
Yes.
And we will discuss these results later.
Next key issue.
Yes, the final one, I will briefly discuss temperatures with the next slide. Thanks. So birds are sensitive to cold and heat stress, and below or above the temperature, humidity, neutral values, and depending on airspeed, localization on the truck, birds may experience cold stress, so discomfort, they will dip into their reserves, or heat stress, so it's compulsory for them to dissipate heat, but it's not always possible depending on temperature, humidity, so it may lead to mortality. So this specific topic of heat stress will be discussed more in detail in the next presentation, so I won't give you more detail. And currently, birds must be protected against bad weather, extreme temperature, and adverse weather conditions. And for instance, in France, it is also forbidden to transport live animals from 1 p.m. to 6 p.m. during heat waves. And long duration transports are authorized if inside temperatures are less than 30 degrees. You can, and we have, so here I have a last question for you. So what are the best practices maybe in your countries for transporting poultry in hot weather? Are there specific practices such as, I don't know, reducing densities or? So it's an open question. You can answer if you have some info to share with us.
it's interesting to also have a meeting with different countries.
Yeah.
So nice to have info on which practices is done in your different countries. This answer will be interesting also for the next presentation of Yann. Density mainly.
Yeah, maybe reduce density or change the transport hour, so mainly during the night when temperatures are lower. Use the curtains also, or ventilators.
Control temperature.
Yeah, okay. Limited waiting time too, okay. Thanks. So please feel free, yes, just after during the question session to give more detail on this topic and what is done in your country. And just to let you know that in the new proposal, it is written that curtains must be used when temperatures is less than 10 degrees. And they also want to limit transport duration under high temperature or to perform only night transport, but with no more details for now. So to conclude, transport duration has a real impact on birds' welfare, but thresholds are not yet clearly defined. Scientific data supports the limitation of the fastening duration to 12-hour max, but there are lots of uncertainties regarding water deprivation. Additional space provides more comfort to the birds, but also leads to more injuries, except during summer. And we have many uncertainties also regarding the future regulation. Everything is not clear right now. So it raises many questions from stakeholders regarding also feasibility and high associated costs. So lots of discussion still must be done between member states to agree on a final version that would be feasible and aligned to really improve bird welfare. And yes, we have a last question now that you have all the basic information regarding these key issues. We would like you to rank them from the most important according to you, what you know and what was discussed previously to the last important. So number 1 and 2 seems to be the most solid scientific basis to be modified or to have a real impact on bird welfare. And I understand this results. And feeding watering, as we explained, it's not that it's not a problem for the birds, but maybe it's not as easy as for the other one to improve the practices. as well as for the available space that maybe provide more comfort, but also more injuries. So, okay. Thank you for voting.
So now there is room for open questions, so you can turn on your mic and ask some question to Laura if you want. It's the room for this. So if you have question, please just speak.
Or if you want to add information or to describe some specific practices in your countries or difficulties or or if you disagree with something I said, or do not hesitate.
Okay. Just turn on your mic and speak. But if not, no problem. We will continue. There is nothing in the chat, Yann. Could you check, please?
No. Actually,
Okay.
no. I don't
Okay.
see anything.
Okay, so we will continue with your presentation. So this is the presentation of the broiler thermal stress modeling, and this is an aWISH outcome done by ITAVI. So Yann, I will.
Thank you, Pauline. So welcome everybody. Thank you. My name is Yann Guyot. I'm in charge of mathematical modeling and climate change adaptation of the poultry sector. And I was in charge in this project to try to find a way to better know what's going on within the truck during heat stress. So we decided that since we were following and monitoring a lot of transport, to switch to mathematical modeling to have a better overview of what's going on during transportations of broilers. So can you please switch, Pauline, to the next slide? So I have a question for you, which is that we call for your intuition. According to you, in the truck, where is the hottest part of a truck during a hot transport? Do you think it's at the rear, at the middle, or at the front, close to the cabin? So basically, it's just to know if your intuition about that.
Okay, most of the answers
Yeah,
is at the
perfect.
front.
Yeah, so most of you will see has a good intuition or a good knowledge about it, as you will see in the presentation. Well, so as you know, there is millions of broilers transported globally and potentially in stressful conditions because of heat and because of hot weather. That might lead, as Laura said, to DOA and eventually, of course, to economic loss. But before DOA, it can also lead to weight loss, according to if the duration is quite long, or maybe meat quality degradation. And also, again, as Laura has mentioned before, it can lead to several animal welfare harsh condition. And this condition will happen a lot more in the future because of climate change and global heat rising. Heat stress will happen a lot. For example, this summer we had in France, we know that we cannot transport animal during daytime, but at night we had 30 degrees at midnight. So we know that this kind of conditions happens already, and it will happen a lot more in the future. So we have definitely to tackle this issue in the future. Next slide, please. So the question we have is that, can ambient condition be estimated within the truck, first of all? So of course, we can set sensors, but can we do it without sensors? It will, of course, lead to reduce the cost because sensors are the cost and you have to check the weather and everything. And it will be time saving because, of course, again, checking everything takes time. The other question we have is how we can extrapolate the measured temperature to all birds, because if we put sensors, maybe we put 1 or 2 sensors, maybe we put them at the rear, the middle, or the front of the crates, but what's happening away from the sensors? So we think that we need to have a more comprehensive knowledge of the heterogeneities that are happening within the truck. And another question is that what would be the air velocity distribution within the crates, the containers themselves? Because, and there is sensors for that, but we think that they are not very suited for monitoring during transport. They are very sensitive sensors and they might be very quickly destroyed by the animals. So we cannot, I would think that we cannot easily assess velocity, and it's a very key parameter for heat stress. So this is what leads us to the idea to use mathematical modeling to know what's going on within during transportation, and especially CFD modeling, which stands for Computational Fluid Dynamics. So please, Pauline, merci. Thank you. So basically, what is CFD? So CFD basically just solve the equations of fluid transportation and temperature transport distribution within a given set or given medium, let's say. It's broadly used almost everywhere in engineering. It's used in biomedical, so you can simulate the blood flow within the heart, for example. It's also very used in ventilations, like if you design a new room, if you design an hospital or whatever, they will always get what will be the best and the optimal configuration of the building to have an optimal comfort for the people. It's one of the big one. It's used in aerodynamics when you make a car or a plane. They always use that, or even urban planning now they are doing to make the cities for heat stress more comfortable. So we use this method. And we have to set some specifications to our problem. The first one is that we cannot simulate every animal within a truck. There is almost 7,000 animals. We cannot design all of them and calculate the airflow passing through them. So we consider them as a porous medium. I will not get into details, but it's very important characteristic. And this porous medium will reflect the capacity, the incapacity of the broilers to let the fluid flow pass through them. So there is a parameter for density and a parameter for body weight. And also, so this is for the fluid flow itself, but it's another specification is that we have to consider the broilers as heaters, because they are heaters basically, like we are. They emit temperature, they emit heat, like us, they emit heat in 2 forms. The first one is the sensible. So the sensible is the heat that will rise temperature. And the second one is the latent heat, which is basically for us, it's sweating, but for animal, it's I lost my word, panting. It's panting, and they will generate humidity and water in the air. So we have to take the specific behavior in the model in order to be more accurate. Next slide, please. So here are the results of one of the simulations. So you can see it's a truck driving within 60 kilometers per an average, for example. And here you have your answers. So most of you were right. The hottest part is on the front part. As you can see, you have the temperature map, which it's a map basically, it's in 3D. You have the temperature map within the containers. You have the humidity map within the containers. And you also have, since it's CFD, you also have the fluid velocity itself. And the reason why the front part is the hottest part It's because the airflow is touching, basically it's touching the truck in the middle, and it creates a very backward stream that will push the heat back to the front, at the front. So the animal, there is very, very few velocity there, and they are getting the heat from the others. So that's why it's very, very less, it's the harshest place in the truck is the one in the rear and in the bottom, as you can see here. Okay, so that's the hottest monitoring we had. So we had them for like something like 14 monitoring of transports. And of course, we had to validate the model before using it as an assessment tool. So first of all, we collected data. So we collected data from waiting at the farm to the slaughterhouse, and you can see here on the temperature that we have this. We have let's say we have sensors at the front, sensor at the middle, and sensor at the rear. And so the rear part is the one that is loaded first, of course, because containers are loaded this way. So this is the part that the temperature increases at the beginning. And you can see that. So what we did that we took, and then since we are modeling only steady state conditions, we take the average velocity, the average temperature and humidity over driving as the one what we want to against the one we want to validate the model. So as you can see on the picture on the top right, basically we are simulating quite well temperature with a good approximation and a little less humidity, which is normal because we always expect humidity to be less estimated because of the capture sensitivity and everything. But we are quite happy with temperature and prediction ability of the model. So now we have a model that is able to have a 3D map that we can rely on the data on the outputs. So it gives a 3D map of the temperature. So and the humidity, how we can transform this physical data that we are simulating into a thermal stress indicators, because we have to gather them together. So next slide, please, Pauline. So the EFSA provided in their journal let's say two indicators. So I just selected the ones because they are mostly the same, basically. And these two parameters are dependent on temperature and humidity. We should never forget humidity, because, for example, for you, if it's 37 degrees and 30% humidity, you feel hot. But if it's 37 temperature degree and 100% humidity, we all die in few hours because we cannot regulate our temperature. We cannot evacuate the heat. So it's always a combination of both. And what they do is that they provide this apparent equivalent temperature, which is heat stress indicators. But if I follow this AET in my truck, what I can see, for example, for the hottest monitoring that we had, is that 80% of my animals are in danger and 20% of my animals are in alert, and none of them are safe. So what we would expect is that in such harsh condition, we should expect a lot of DOA. And actually, please, Pauline, this is not what happened. As you can see here, the hottest monitoring, so the one with 80% animals in danger, the dead on arrival were not higher than any of the ones that we monitored, with very few dead on arrival and in not called mild conditions. So the question we had is that we think that in these indicators, two factors that are not taken into account might explain this discrepancy. The first one, as I said before, is the air velocity, because it's very important. You can imagine for you as well, if it's hot, then it's hot, but if you have a little wind, you feel much better, or if you drive a motorcycle and this kind of thing. So air is very important. And the other one is exposure time. If the animals are exposed 10 minutes or 2 hours, it's definitely not the same. So we think that without taking these two parameters, the indicators we have are not good and not enough to assess it. So please, Pauline. So how to take them into account? The first one, so the air velocity, from the literature, from a paper from Birg et al. They designed what they call an effective temperature, which could be like a felt temperature. And it takes into account temperature, humidity, and velocity. And it calculates, according to these three parameters, it calculates a body temperature rise, because the real definition of heat stress, this is body temperature rise. It's like for us, it's the same. If temperature increase, so an animal, a broiler is around 41 degrees on basic. But if temperature rise, after 1 degree, it will have a problem in terms of performance. But after 3-4 degrees, we know that death will happen. And these indicators, it's also very important because, and very well made, because it takes into account that if the air temperature gets close to the body temperature, you can blow as fast velocity as you want, you will not decrease. You can also imagine that for you. If we blow very hot air on you, if you feel hot already, it will not get you colder. So, and it will not cool you down. So that's something that is taken into account in this indicator. And the other one is the body increase depending on time. So as you can see on the 3D graph here, if you have effective temperature, let's say around 32, so on the left of the picture, and then you can face this effective temperature forever. You will remain in the green part. Your body temperature will remain below 1 degree, so it's fine. But then if you face 40 degrees of effective temperature in 2 or 3 hours, in 2 hours, the animal will be dead. Basically, yeah, the body temperature rise would be so high that death will happen. So now we think we have a tool, an indicator taking the 4 parameters together, and we want to check now in our hottest monitoring, is it going to show that this DOA we had, which was lower than the others. So please, Pauline. So this is the one, our hottest monitoring. So you can see the ET. So I forgot to put ET. So the effective temperature is displayed on the top left. And you can see the animation on the right. So the one on the bottom is just the increase of body temperature. So 0 means no stress. They will remain the basal temperature. And then you can see at the rear part, always this part, the animal will start to have an increase of temperature. But what you can see on the bottom left picture is that at slaughter arrival, most of my animals, the animals of this monitoring, were still in the good conditions. So it explains way better the dead on arrival that we have seen, the below one. You can see most of the animals are not in danger, are not in alert in these conditions. They are just fine. Okay. So now we think we have a tool that is working. We can make simulation, extrapolations. What will happen in the future? What will happen if my conditions are like this or like that? So we simulated here, like as I told you, one of the conditions we had in France this summer, which was 30 degrees at midnight, 40% humidity, and we tested it. We tested what will happen. And what we saw is that after 1 hour, not even before, some animals start to feel some stress again, the real ones. And between the first and the second hour, we have animal starts to feel very bad, like the temperature, the body temperature more than 2.5 degrees more than the basal, which starts to have stress. Very good big one. And then after 2 hours of transport in these conditions, the red are coming, which basically will lead to DOA. So we know that in these conditions, after 2 hours, problem will occur. So okay, fine. So what can we do? So we can switch to some levers. Since we have a tool, a simulations tool, sorry, we can test some stuff. So the first one is say, go Pauline, please. The first one says, if I reduce the density by 10%, like it's usually applied, what will happen? So you can see that at the beginning, you have exactly the same stress distribution within the truck, a little bit lower, but it can be better to have this sort of density for long trip, because at 3 hours you can see that you have way less animals in very harsh conditions than without applying the 10% density reduction. But another one, since the problem always occurs at the front, can I just leave these containers empty? And the other ones, all the others, with the same density as before. So this is what we applied here. And as you can see, it's a better condition than just reducing density overall. Because even after 2 hours, you have very few animals in small heat stress, and no red is appearing. Actually, we wanted to try. I'm trying now that if I remove only the bottom one, I'm testing it right now to just remove the bottom one if it's even better. And and also the good point is that you have better condition and you transport more animals, because removing 2 containers over 22 containers, it's 9% reduction instead of 10%. So more animal, better conditions. So we think that is the best solution one of the best solutions will be this. So as a conclusion of this work, we think that now we have a tool capable of quantifying the thermal stress, which are based on weather condition. We can simulate different weather conditions. The loading, we can change the density, and traffic, because now I simulate, let's say, average velocity of 60 kilometers per hour, which is normal for a truck. But what happens if it stops? What happens if it has to drive with like traffic jam? It has to drive for 10 kilometers per hour. I think condition will be way harsher. And also we think that this tool can provide recommendation and mitigation strategies. Of course, some future work still needs to be done. So we want to incorporate variations in driving speed. So basically, as I told you, this model can, as we think, easily extend it to other conditions than just driving. We want to test it on the waiting time at the slaughterhouse. So the animal will be stuck, maybe some fans, some big fans, and check, and everything can be done. So it's just the same, just geometry change. So we want to, we are already multiplying monitoring to add more weight to the model. And of course, we would like to see the mitigation strategies we provide, we advise in the real transport to say, okay, what you told us, it's indeed more efficient. And the last one is because this type of modeling requires some expert hand to make it and to make the simulations. And we are thinking about how the output of the simulations can be provided to the people and to the people engaged in boiler transports, either within like a chart of, or maybe a meta model. We are thinking about it right now, so how to provide it. So I can see that there is some questions in the chat. So we have one of the stakeholders, part of the aWISH project, had recorded some questions and some ideas and what she thinks actually about this model. But I think we can already answer the question in the chat, Pauline.
Yes, I don't see anything, but if you see this question, please go on.
The first one, yeah, the question was answered. Voilà, so I will not answer it again. And it's about empty cages. And the next one, will the model work also for cold stress? Yes, it could. Some adjustments need to be made, especially for the curtains. In this case, curtains are not present, of course. I think one adjustment that should be done for cold stress, would be we have to add the curtains to the truck. So because curtains, maybe they are not very permeable, maybe some air can go through. I don't know. There is winter curtains, there is summer curtains. So I think we call about the winter ones. So yes, some little adjustment. But of course, yes, it's the same principle. Just instead of 30 degrees, I said 5 degrees. 0 degrees. And then we can have a map of the temperature within the tray, so no problem. So as I said, I think we will switch to so we have a recorded video of 5 minutes of, Jorinde
Yes.
Mulder, she's from Plukon, and so she's part of the project, and she had some, she couldn't attend today, so but she wanted to share some overview with what she think about what's been done with the project.
She is part of the aWISH project and the pilot 3 of the project in France. So we had a short interview together. So I will just.
And after that, if you have any more questions, please feel free.
Tell me if you heard. Well. You are part of the aWISH project, as Plukon Group is a partner of this project. So could you first present yourself and maybe have 2 words on the group you are part of?
Yes, so my name is Jorinde Mulder. I'm working for Plukon Food Group, and at this moment I'm mainly working on projects that are related to digital monitoring of animal welfare inside of the slaughterhouses and all the monitoring that comes with it, and the developments that are also part of it. So Plukon Food Group is an international food company. It's one of the biggest players actually in Europe in poultry meat, but also a large part of the company at this moment is producing fresh and pasteurized meals and salads. Plukon Food Group has over 40 different locations at this moment, and we are located throughout Europe in 7 different countries.
Okay, thank you, Jorinde. Regarding the last presentation done by Yann about broiler thermal stress modeling during transport, could you tell us what interest Plukon have in this type of development?
Yes, I think it's a really interesting development, especially because it gives us actual insight in the effect of the outside temperature combined with transport time related to heat stress. At this moment at Plukon, we work with a heat protocol, but it's purely fixed on the outside temperature, and we don't incorporate any additional factors in that. So normally above a certain temperature, that would mean that, all the crates would have a lowered density inside of the truck, but it's the same for the different crates. However, if you check the model, it might make more sense to change the density in crates that are closer to the truck or leave some empty crates in between to improve airflow. So I think we can learn a lot from the model in how to handle actually our heat protocol or how to improve it.
Okay, and in practice, concretely, how would you use it in Plukon in the future?
So within Plukon, I think the model can really help our planning department by assigning the correct number of trucks to each farmer, because of course, with the temperatures increasing, we have this lower density already, but now it's the standard, so we know exactly how many trucks we need to send. I think we should start earlier with that, and the model can help us by actually sending the right amount of trucks to the different farmer. But of course, the model also needs to be able to be used by the drivers, because the drivers still go to the farmers and they should know the positioning of the crates. So where should they put the empty crates, on which position should they put like the crates with a certain density in it. Of course, the model needs to be filled for every flock to use it this way. So we need to find a way to automatically fill it with the data of the outside temperatures, and maybe we can integrate it with our existing infrastructure in which the transport times or the location of the farmers are incorporated, to give a good indication to our planning department.
Okay, and what needs to be improved to make it usable for you, and Plukon in general, which data need to be added, for example?
So what would be really important for us is like a clear overview of the density of almost every crate inside of the truck. So it should really say, okay, this crate should have a certain density, and then from this point the crates can have this density. So really, yeah, usable for the drivers. But also it would be really helpful, as I just said, if it can be linked to our existing systems to get the data there automatically instead of putting in an actual manual handling to get your data right.
Do you think it could be also interesting to have like a prediction of the dead on arrival, for example?
Of course, we want to have 0 dead on arrival, especially caused by transport. So it would be interesting to have a prediction of the dead on arrival, but it would be even better if we can use the new system or your new model to lower the dead on arrival in total. It would be helpful to have the dead on arrival in there. But of course, the idea is that by changing the protocols for the high temperature, the dead on arrivals will be much lower.
Okay, thank you, Jorinde. Okay, so Yann, you maybe you have some additional things to say regarding this point of view of Plukon?
Well, yeah, I think that we agree of what should be done. As I said before, the first one is that it has to investigate what are the best parts, what are the best location to avoid density. So that we agree about that. And the second one is that again, we need a very simple tool or very simple calculators or whatever, what form it will be. They can follow the real practice that, let's say tomorrow we're going to be very hot in this location. I have this farmer to collect the broilers. What should I do practically? So as I said, at the moment the model cannot be used so directly, so straightforward. So that we can switch. We are thinking now how to switch to something very simple that we take into account, and this is what I mentioned by using, like for example, a meta model. So sorry if it's. So basically, we run the simulation, many simulations, basically, and then we make a very simple model out of the output of this many simulations. That would be a very simple one. Or either we make a chart of this many simulations. So this thing, we believe, can be easily used by people in practice. And the final one about DOA, I don't think we have enough monitoring about that we can make a predictor of DOA. But I do believe that by just taking into account the body rise temperature, it's a good proxy for DOA. So I would like to assess it. I would like to be sure of it. But I know some people in Netherlands, working on DOA depending on temperature. So I think we will try to make something out of it. But it's quite difficult to predict DOA for the moment.
And maybe we have the data to validate or to.
Yeah, but I'm not sure we have enough to make a very strong DOA predictor at the moment. That's it. And I can see there is a question as well in the chat. If we plan to check the impact of nebulization, I think it's you mean the one of, I think it's the concept of adding steam, not steam, adding misting indeed within the truck. I don't know if it exists within transportation. We can chat if you want to open your mic. Please be welcome. You're welcome. We are first of all, if we talk about modeling, actually we are simulating this process within a building, within a broiler house. We are doing this now. It's another project, but we are able to do it. Within transport, I don't know if by checking the impact, you mean the impacts on welfare, I guess, but I think it will condensate very well within a truck because the density is so high. I don't know. I don't know about applying misting during transportation. Probably, I don't know.
No, I don't know too. There is another question. Yeah, does transport mortality also mainly occurs at the front of the truck?
We don't have the data, unfortunately. We have the DOA declared by the slaughterhouse, but we have no details of where they happened. Most of the transport we had were not in harsh conditions, so harsh conditions. The harshest one was 25 degrees. Because it's difficult to plan it and to know when it's going to be so hot. So we didn't really record hot or very hot one, unfortunately, to assess what you mentioned. We expect it, but we don't.
Maybe we can ask the question, Yann, for interactive
yes, please.
Session.
So yeah, basically what you guys think improvements can be done in the model in the predictor we shown that could be done or you would like to see.
There is one more years of project so maybe we could have time to include some more improvements, so we are open to have your suggestion for adding some more things in the model, some more data, etc. But if you prefer, you can just turn on your mic and just ask your question or tell us what you want. Okay, so this model is perfect.
I think it's already perfect. Or maybe I think we already mentioned the problem.
Yeah. There is some suggestion.
More field confirmation. I agree with that. But every field, if you have any, we will be delighted to incorporate them. Especially, I mean it because it would be in a different condition, different country, different everything. So it will be interesting and to add some confidence and some that the model is able to catch the variability for different situation. Yeah, okay. Well, yeah, this was mentioned. Traffic jams. Yeah. Basically, we want to do that as well. Equal stress. Yeah, again, yeah. I think it's a big deal to switch to cold stress. So just need to be done. And I don't know if we know so much about the condition that leads to cold stress as much as we know the conditions to lead to heat stress. We know that about in terms of performance, in terms of consumption within the farm, but I don't know. I'm not an expert in cold. I have to check. CO2. It's a very good question. We were monitoring CO2, but we saw a lot of variation within transport, which is completely normal because you are surrounded by cars and trucks that are, all of them, exhausting a huge amount of CO2. So monitoring CO2 within a truck, it doesn't, I don't think it leads to, of course, you can monitor it and have an idea of what's going on in terms of CO2, in terms of modeling it It's very difficult because yeah, you have to take into account the environment of the truck itself, and you don't know about. Basically, if you are stuck in a traffic jam, I think the CO2 is very high. But if you are driving on the countryside road, I think it's like 400 ppm. So yeah, it's almost impossible to model it properly. Different curtains. Yes, I know. Well, if the curtains is well sealed and well insulated in terms of heat, and it can be done. But then if you have like what they call summer curtain, that's basically it's a net, or kind of a net, of small holes inside, it can be difficult to simulate. Some approximation needs to be made, I think. But thank you for this overview.
Thank you, yes. So if you want, we have some room for open oral questions. If you want, you just turn on your mic and speak, no problem. If you have some question for Yann, Laura,
Even remarks.
me, or some remarks, and etc. Don't be afraid. No. But if there is no question, we also in the presentation there is our mail. So if you have some specific question afterwards, don't hesitate to contact us in private. No problem. So thank you all for participations, and bye bye.
Have a nice day. Thank you. Everybody.
Have a nice day. Bye.
Thanks a lot.
Bye.
Thanks a lot.
Thank you very much.
Thank you. Bye.